Okay, now that we have the go command, now it's the time to take care of the objects, because we have now dynamic locations, but we have only this fixed string here. And we really want to see the objects that are indeed on this location. And that will take us back to our header file. We already had a structure, a data type that we created specifically for dealing with locations, and now we are going to do a similar thing with objects. So I'm going to define a structure object, and this is not at all in the sense of object orientation, which is something that we are going to see with other languages, but this is really like a physical object of the world, like a lamp or a key. So we define the struct object, and I must not forget to add the proper semicolon. And here we want to have a description, and the description is something like a key. But also we want the name that the user will call the object when making commands. For the description will say, here's a key, but the user says take key. The user doesn't write take a key, it says take key. So I'm going to call this shorter name of the object tag. And the object will be somewhere. Now see that we are reusing the object, the data structure that we created before. So we're basically saying that the object has a pointer to a location. That's the location where this object is currently located. However, I want to define the notion that the object is with the player. It's in the player inventory. So I'm going to just say that inventory. We can use, for instance, -1 again. Say inventory. That would be the location, and something is with the user. Otherwise, it's going to be in one of the game locations. Save this file. We close this window. We're back here. Oh, because we are already including that header file, we already got all these changes here. So now we have to define the objects of our world, same way that we define the locations. We are going to define some objects, an array of type object called objs. In this array, we have a lamp, and the tag is lamp. And this is on the office, right? So we say it's in the location lock office. But because this is a pointer to a location, which means this is the address pointing to the memory location where we have this location structure. I know this sounds a bit confusing. Let me say that with different words. We have a certain place in memory that has an address, and that place contains the location struct. In this case is this location struct. And in order to provide that address, we use this ampersand operator. So this basically saying at address of the office location inside the location array. So this is how we put inside our objects a reference to a location. And same wise, we say that the key is in the stockroom. Again, lack of semicolons causing havoc. Yep, being a programmer is caring about semicolons all the time, and commas and dots and parentheses, and yeah, that's the lot we've chosen. So we have our objects that are defined, and now we have, every time that we enter a room, we want to see what objects are in there. So the same way that we had like a process input here, I'm going to add here, let's call a function. We can call it list objects. And we have to say where we are, right? What is the current location? So that would be probably we have to pass the address of that. And now let's declare this function. So it's a list objects, and we get a struct of the type location, a pointer to a structure of the type location. I'm going to just call it lock. And now we have to iterate through the array of objects and check if the location matches the current location. If it does, then we print it on the screen. The question is how to iterate across this array. So here we need some tricks. There are many ways of doing this. I think the most intuitive is to just use a for like we had in BASIC. And we need a index variable that's typically called I. And we want this to, the end condition of the loop is when I matches the length of the array. In our case, we know that our objects array has just 2 entries, so length is 2. But I will call obs. For now, let's just put something here, placeholder. I'm gonna populate this with something later. Say, okay, if when we reach the length of objects, then we increment our index counter. But we also need the object, right, that we are going to manipulate. So that's the type struct object. And it starts just pointing to objects. So this is going to point to the first entry. So right now we have object as the first object, the lamp. And every time we increment the index, we also increment the pointer to object. So you see this obj is a pointer, and we are going to increment that pointer, which means we are going to point to the next object in that array. So this way, every time we run a different iteration of this for loop, we have a different obj and pointing to the next one. So in our case, we want to check if the object location is the same as the location that we are in now. And if it is, we want to print UC, then it's like you see a key, you see a lamp. Here it's, and because object is a pointer, then we use this little arrow here to dereference the different parts of the struct. So this is how it works, and in the end we return. And that's how the list objects function works. However, we have this object's length, right, that we have not defined. So we have to define this thing. You see, one way to do this is I could just come here and say, okay, we have two objects, so the length is 2. So, and that would work. By the way, let me show you how this works before we move on. It's just in the wrong spot. Let me show you. Just a second. I want to make sure that I haven't made a mistake here. You see, oh, yeah, we want to get rid of this one because this list objects now it's going to take care of it. So let's try it again. You see a lamp. Go south. You see a key. It's working. However, I promised that I would show you a slightly more decent way to deal with that, because one thing I don't like about this thing we've done here is if we add more objects, we have to come and change this. That's very easy to forget. So basically, we can calculate this dynamically, but that depends on the memory size of the object structure. And we know the object size of of a structure using this size of function. So the size of the entire objects array. So this is going to be the entire size of the array divided by the size of just one element. Any element will do. I'm going to use element 0 here. So what's this division is going to result in 2. And if we increment, let's say for the sake of argument that the size of an individual object was 10 bytes in memory. I'm just making this up to make it easy. And then if we have a list of 3 objects, that's going to be 30 bytes. So we have 30 divided by 10, and we have 3, and that would be the length of our array. So this way it will always work. We don't have to manually do anything. So let's save this and see that it's still working. Yes, it is. Okay, that takes care of listing the objects. The next thing we need is to be able to pick up objects and drop objects.